Welcome to this lecture. This is a lecture which is basically based on the special theory of relativity, and in this lecture I am going to talk about space-time continuum, four vectors, light cone, and a brief idea about the causal events. And for this I follow two books. One is the Classical Electrodynamics by S.P. Puri, and another is the very classical book that the title of the book is The Concept of Modern Physics by Arthur Weiser. So, in the earlier lecture, I talk about Lorentz transformations. Now, in this lecture, I will going to talk about special theory of relativity. And the idea was given by Einstein. So to uncover the principle of relativity, Einstein studied critically properties of Maxwell's equation. And negative results of Michelson-Morley experiment. And he made some postulates. And what are the postulates? Let us have a look at those postulates. So first postulate is that all laws of physics are the same in every inertial frame of reference. And the second law is the speed of light is independent of motion. Motion of its source. And the consequence of the second postulate is that speed of light is same in all inertial frame of reference. And we may call it as a universal constant. So let us try to explain that how Einstein proceeded. I will trying to make or trying to understand at my own way. So suppose there are two frames of references. One frame of reference is this, and another frame of reference is this. So let us call this as S frame and let me call it as S prime frame. And this frame of reference is moving along this direction with velocity Vx. And here there is a source of light. So a source of light, when observed from these two frame of references, say this frame of reference is a stationary frame of reference, and let me call it as this frame of reference is a moving frame of reference. So now when S measured the speed of light, then for it seems to be c. But if I go to the second postulate, then the speed of light should be c. So I can write down that it should be c for the reference for the frame of reference c prime. That means both the frame of references measure the speed of light as c. So this is possible if and only if we will think in terms of this frame of reference. Say it is S and it is S prime. So this is a source of light. So that means if it is moving with this direction, so that means if I assume that means if from this moving frame of reference, if I'm trying to look at this, that means for the observer, this frame of reference looks like that it is moving along this direction. And in the similar fashion, the source of light will also seems to be moving along this direction with the same velocity. So if I think in terms of this, then I can say that for this observer, the velocity of light should remain the same, that is c. So in this way I am trying to understand it. Now let us come back to the mathematical description of things, that how things can be described mathematically. So what Einstein did, he used the fact that speed of light is precisely known. No, this is a one fact, and it is assumed to be always a constant, and is always assumed to be constant everywhere, irrespective of space, no matter how it is generated, means how the light is generated, and the direction of propagation. It is independent of everything, right? So it is always constant. So this is the idea which Einstein taken. Now, what he did, he draw a coordinate system in this manner, and it is a S frame of reference. Say from its origin, if flashlight is coming out as a spherical wavefront in this direction, it is emanating in this direction, right? And say at some time it will be at this point, and for this frame of reference it will be here, and say it covered a distance d, right? And at t naught is equal to 0, when light is on, and it will take some time to reach at point P, and it traveled a distance d. So that means the time taken to reach a flash of light at point P, it is d upon c, if this is the d separation. Similarly, if frame of reference is moving with velocity v in this direction, then this is the distance traveled by this flash of light. Say, now again, it will take now the distance traveled will again remain the same, but time taken will be different. So that means t prime is equal to t by c, or d prime by c. I come back to this point later on, but first of all, let me talk about it. So that means this distance is equal to ct. But if I apply distance formula, so using distance formula, this x square plus y square plus z square, this is nothing but the d square. And this d is nothing but it is c square t square is equal to x square plus y square plus z square. Right? And let me rewrite this equation as this x square plus y square plus z square minus c square t square, and it must be equal to 0. But if I try to look at this diagram, the time taken by the flash of light to reach at this point P, it is t prime, and this distance is basically, let me call this distance as d prime. So this d prime is equal to x square plus y square. I'm in the prime frame, so it is x prime square, y prime square, and the z prime square. And from here, it is ct prime. So c square t prime square, using this, it will be equal to x square plus y square plus z square. Or I can write down it as x square plus y square plus z square, sorry, and prime should be there, minus c square t prime square. And this is equal to 0. So what I can do, I can write down it as, if I compare these two equations, so that means this x square plus y square plus z square minus c square t square, it must be equal to x prime square y prime square plus z prime square minus c square t prime square. So this is the equation which I am getting out of it. And this was the equation given by Einstein, and this equation was further used. We can use this equation to derive Lorentz transformation equation. Right. So this is one thing. Now let us try to understand this equation. Since I am writing it as x square plus y square plus z square plus c square, minus c square t square, it must be equal to x prime square y prime square plus z prime square minus c square t prime square. But if I try to look at this part, negative sign is sitting here. Can I make it positive? There is a possibility that we can make it positive. In this manner, means C is not C T, it is simply, but it is simply IC, iota C. Iota is a complex quantity, right? So complex number basically. So it is x prime square, y prime square plus z prime square plus iota ct prime whole square. This formula looks like a distance formula. Or distance of a point from origin. But not in 3-dimensional space, but in 4-dimensional space. This also, but in S frame. Similarly, this also looks like a distance formula. In 4 dimension. In S prime frame. But it's not a simple space. Here, the 3 are the position coordinates and 4th coordinate is the iota ct. So it is basically a time coordinate. So that means it's not an interval. It's not a distance of a point from origin of a point, but it is the distance of a point in space-time. It is not a distance of a point in space, but it is the distance of a point, or it is the interval between events. So it is basically known as the space-time interval. So we call it as space-time interval. Right? But things are happening from origin. And in some books, this equation can also be written as c square t square minus x square plus y square plus z square is equal to c square t prime square x prime square y prime square plus z prime square. So this equation basically, which I am getting, it's just the idea of the space-time. So new concept will be developed, a concept of space and time. Thus, x, y, z and iota ct, these are the position vectors, or these 4 points will represent a vector in space-time. And this vector is not a simple vector, but we call it as a 4 vector. This is the idea of 4 vector which is emerging out. That means, let me remind Newtonian mechanics. So, according to Newtonian mechanics, space and time are independent of each other. But from the study of, means I am concluding from here now, but from the study of special theory of relativity, we learned that space and time are independent, sorry, not independent but interdependent. Interdependent and can be treated on equal basis. And this four-dimensional space-time continuum, is known as Minkowski space. Minkowski space. Why it is called Minkowski space? Because Einstein is a student of Hermann Minkowski, and he suggested that this theory of relativity best understood if we take a four-dimensional space. That's why it is known as Minkowski space. That means, found that the spatial theory of relativity by his student Albert Einstein could be best understood as a four-dimensional space, and because of that it is known as Minkowski time or the space-time, right? And this are taken from the Wikipedia. The source of this is the Wikipedia. It is mentioned there. Now let us talk about briefly the idea of light cone. So to develop the concept of light cone and causal events, let us again consider the equation that an interval x square plus y square plus z square minus ct square must be equal to x prime square y prime square z prime square minus ct prime whole square. And these are the spatial coordinates, and let me represent this as r. So it is r square minus c square t square must be equal to r prime square minus c square t prime square. And let me write down it as r square plus iota ct whole square. It must be equal to r prime square plus iota ct prime square. right? So I can express this equation in this way. But now let us define an interval. Let us consider two events. And these events are given by 2 points, x1, y1, z1, and t1. And another event is at x2, y2, z2, and t2. So interval between these 2 points can be defined as we define in the 3D space. So that means this interval, it can be written as delta square is equal to c square t2 minus t1. It is simple distance formula. I am elaborating three-dimensional distance formula from 3D to 4D. x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Right? Or if these 2 points are infinitesimal, so that means for infinitesimal interval, this equation will reduces to dr square is equal to c square dt square minus dx square minus dy square minus dz square if I open this bracket. So I can express it as c square dt square minus dr square, right? So this is way that how I can define interval. Now let us try to understand this equation. This is a very important equation. ds square must be equal to c square dt square minus dr square. Let me draw a diagram. This is the axis. And let me call this as r axis, and this is ct. So it is imaginary part and this is the real part. So now different cases are there. So first case is that ds is equal to 0. Another case is that ds is greater than 0. And third case is, let me, yes. So this is imaginary axis and this is real axis, right? Now what I will do, yes, there is a third case that ds is less than 0, right? So if it is so, that means this c square dt square minus dr square is equal to 0, or c square dt square is equal to dr square. I can express as c dt, it must be equal to plus minus dr. Or in other words, I can say that ct is equal to plus minus r. This is one and same thing. I can express it in this manner or this manner. Different books will take different notations. And here it is c square dt square minus dr square is greater than 0. So that means c square dt square is greater than dr square, and c dt greater than equal to mod of dr, or c dt is greater than r. There is another possibility that c square dt square minus dr square is less than 0, or c dt is less than equal to mod of dr, or I can and here it should be t, yeah, ct must be greater than less than mod of r. There are the three possibilities. So let me try to understand it. So it is a basically R, it is a three-dimensional, right? And it is a CT. So that means, but if I replace 3D with a one-dimensional, then it's a one and same thing. It's better to visualize. So now I will do one thing. I will draw now it will be much better. Right? So this is basically a cone. This is a region. It's a so that means this CT is equal to plus minus R. So that means if I will plot it in the 3D, means R represents 2D or 3D, then it looks like a cone. So this CT is equal to plus minus R. If it's like a R, so that means this equation is basically CT is equal to R, and this equation is CT is equal to minus R. Now let us consider three possibilities. So if t is equal to 0 and t is equal to and I will write down time here. Okay. So if t is equal to 0, t is greater than 0, if t is less than 0. If t is equal to 0, so that means this is the point, t is equal to 0. So that means I am talking about the present, means current time. If time is greater than 0, the time is positive. So if time is positive, what is the meaning of that? The meaning of that, it is a future. It's a future. So this is the future. And this point is the present. And this is the past. Means if it is less than 0. So that means this light cone will tells us about the present, past and future. And at this point, the speed of light, because this is Ct is equal to R, so that means in this region, the things are happening with the speed of light. And such events are known as light-like events. Light-like events. And events Ct is greater than equal to R. These events are time-like events, and these events are known as space-like events. So if I try to look at it, Ct is greater than R, so that means if I am considering an event, so at this point this C delta T and it is delta R, so that means this C delta T is greater than this delta R. So that means this is basically a time-like event, but events which are occurring in this region, I am considering one event here and two events here inside the cone, and there is another event second which is occurring in the space-like, means outside the cone. So that means in this region what is going on, the speed is less than speed of light, and in this region speed is greater than speed of light, right? Then this inequality will be possible, and this inequality will be possible if it is less than the speed of light. So that means if I know the future, means present position, and if that means I know every event too occurring in this inside the cone region, and this is any line which is inside this cone, this is known as word line. So that means the events occurring inside this cone, these are known as causal events. Means I can predict their present and the past. That means cause and effect. So that means inside the cone, the events are, that means inside the cone, events occurring in the light cone are interrelated, and we can predict their past and future. Predict their past and future. That means there is a causal relationship between the events. Causal relationship between the events. But on the other hand, in this region, means this region and this region, the events lies outside the events lies outside the light cone, and events occurring here are unrelated. That means event 1 and event 2 in this region, they are not related to each other, but the event 1 relating to this event 2, if it is inside the light cone. That means there is no causal relationship between the events. Right? What is the meaning of causality? Because here I am talking about the causality. So let me define the dictionary meaning of causal or the causality. Causality means, the dictionary meaning, the relationship between cause and effect. And also another meaning is the principle. It is the principle that everything has a cause which is happening. Everything has a cause. These are the two definitions of causality. So that means in this article I started with the special theory of relativity. I talk about four-vector continuum, I talk about light cone, and finally I talk about the causality. So thanks for watching this video.